You're going to have a message matrix. You're going to need an encoding matrix. And then when you multiply those two things together, you'll get what's called the encoded matrix. That's our secret that we're going to be sending along to somebody else, so that if it got intercepted, nobody would know what it really says unless they have something. More on that later. First, we're going to assign a key, and we're going to keep it simple. This is what's going to be called your character key, and a character key simply assigns every letter of the alphabet to a number. Now you'll notice here we have the number 0 and we also have the number 27. 0 is going to be used to represent a space, and 27 is going to be used to represent a period. Most codes and ciphers, though, they won't use those. Now the second thing that we're going to do is translate our words into numbers. So we're going to start out with this. I am a rock star. And yes, that is a picture of Mr. Muscarella along with one of his favorite two sisters. That's my sister Maureen with me. And I was visiting her down in Atlanta. So we're going to translate this using our character key into numbers. Now when we do that, I'm looking at the letter I, and I corresponds to the number 9. Then I have a space. Okay, so that's going to be 0. And then I've got an A, and an A is a 1. So I'm going to take this and translate these words into a string of numbers. And I'm going to put a dash in between each one. So go ahead and hit pause and do that now. When you're ready, come on back and see if you at least got those translated correctly. So how did you do? Hopefully you rocked that one out and you didn't make any careless mistakes. So there's our string of numbers. So we've got this string of numbers, and what we're going to do next is we're going to go ahead and write our number sentence. That's going to be our message matrix. So we're going to take that string of numbers and we're going to write it as our message matrix. Now, to create our message matrix, we're always going to want to use a matrix with 2, 3, or 4 columns, and you'll understand why in a little bit, but we're always going to do that. Now, if we count how, we go through and we do that, notice there's only 17 letters. So that's not something that's easily divisible by 2, 3, or 4. So in this case, I'm going to go with 3 columns, and I got 1 space at the end. So I'm going to have to fill that in with something. So I'm going to use a dummy spot. And at the end, I'm just going to use space for that. And the space from our character key was a 0. So now that I've got my message matrix, I'm going to multiply that by my encoding matrix. Now the encoding matrix, I get to make that up. So anything that I want to use for my encoding matrix, I get to make that up. But that has to be a square matrix. That's very, very important. Got to be a square matrix. So that means it's got to be a 2 by 2, a 3 by 3, a 4 by 4, etc. We're going to multiply those together, and we don't have time for this. We've got technology these days, so we are actually going to go ahead and use our calculator to do that, and then booyah, we will end up with this lovely little thing right here. So the fourth thing to do after we choose our encoding matrix, we got to multiply that together with our matrix, our message matrix, and shazam, we get that nice long big old whomping matrix. Now, one of the things that's kind of neat here is check out, and I'm just going to pick on the 0 because that was our spaces, but we've got 1, 2, 3, 4, 5 of those in our message matrix. Now, those 5, notice them in our encoded matrix all the way over on the right-hand side. They're represented by very different numbers. None of them are the same value anymore. So that's going to make it very difficult to decode unless you have the key. Now the last thing that we're going to do is we're going to take our encoded message and we're going to write this as a string. So we'll start with 37, then 0, then 25, and go all the way down until we get to our last number, which in this case is negative 18. This is what we would give to somebody, and that somebody is either going to take it to somebody who it's intended for, or maybe they were the intended person. That person will then work on decoding the string of numbers that they just got. Now, when it comes to decoding, decoding can be a real pain, and this is where the two things are that you need in order to do this using matrices. You're going to need the inverse of the encoding matrix and the character key. So first, let's go to our encoding matrix. Now, our Encoding matrix was the 4, -1, 2, 3, 0, -2, 1, 9, 7. So we got to find the inverse of that, and then, man, look at that ugliness right there. 18 over 149, 25 over 149, blah, blah, blah. So that's the gross thing that is going to be the inverse of our encoding matrix. So we're going to need that here in a little bit. One of the things that I want to notice about my inverse of my encoding matrix, check it out. The dimensions, I've got a 3 by 3 matrix. So that tells me if I'm the person decoding, when I go to take my string of numbers and write it into another matrix, I'm going to need to do something here that's going to help me with a 3 by 3 matrix. So check this out. Since the inverse of our encoded matrix is a 3 by 3 matrix, we'll need to place our string of numbers into a matrix with 3 columns. Well, that doesn't seem so bad. So we just go ahead and do that. 37, 0, 25, and so on, all the way down to our last -18. So we're going to put that string of numbers into a matrix that's got 3 columns. Now the next thing that we're going to do, here's where the grossness comes in. We're going to need to multiply that encoded matrix by the inverse of the encoding matrix. So, yeah, yuck, gross. When we multiply those two things together, look at the grossness that we come up with. Now, of course, we're going to use our technology to help us figure this out, and then bam, check it out. Now, when I did this on my calculator, I got this funky thing here in one of the entries. I got -1.8 and then this e within -12. So I've got to understand what that means. If you don't understand what that means, here's your quick lesson on it right now. That e to the -12, that means times 10 to the -12 power. Whoa, man, that thing's huge. Or is it? Since our exponent would be -12, that means from where the decimal point is, I would move it 12 places to the left. So that essentially means that my number would be -0.11 zeros and then an 18. Oh, goodness gracious, just call that 0. Because that thing's so small it doesn't even matter, so we're going to just call that 0. So what we've got to recognize is that that value is the same thing as 0. So now I've got this matrix as 901, 1301, etc. So that's the matrix that I'm working with right now. And I'm going to go and I'm going to write that as a string of numbers. So I'm going to write out that string of numbers. Now here's where that second thing that I needed comes in handy, the character key. So I'm going to take that character key and I'm going to change all of those numbers back to letters. So alright, so my 9, that is the letter I. A 0, alright, that's a space. The number 1, that is the letter A. And I would go through each one of those pieces to help decode this. And then when I'm done, I should end up with this message. I am a rock star. And if you could follow all that, good for you. That means you're a rock star too. So this is me and my younger sister Maureen wishing you a peace out as you try and work on your own coding and decoding.